we're going to take a look at the composition of trigonometric functions and their inverses. Now, this is really more just about practice than anything, although there are some applications where this comes up. Really, we want to make sure we can think through going forward and backwards and making sure that we have a clear distinction between what's happening in each of those situations. So we're going to start off by calculating the inverse trig of a trig function. Now, in this case, it's really just about doing the computation correctly. So for example, if we have inverse sine of cosine of pi over 4. This at first looks complicated, but all we need to do is follow our basic order of operations, start from the inside, and work our way out. So let's take a look. Cosine of pi over 4. This is a known quantity, so we should be able to use the exact value. And whenever it's a known quantity, you should use the exact value. Cosine of pi over 4 is going to be square root of 2 over 2. And now we're going to take the inverse sine of that. So again, you have to sort of think about the unit circle chart that we have. You find the root 2 over 2 and figure out what angle corresponds to it. It'll only take a moment to realize that this is going to be pi over 4. Notice that the outside function here is an inverse sine. An inverse sine results in an angle, and that's what we have here. So this all makes sense. Now, in this particular case, we have a mixture of two different functions, and it turned out that the angle going in is the angle coming out. This happens by coincidence in this case. It doesn't always happen. And in fact, you could even have inverse sine of an angle, and that angle will be different than the final answer. And this is because you need to pay attention to the domain and the range of the function that you're looking at. So let's do an example like that. Let's do inverse tangent of the tangent of 3 pi over 4. Okay. Let's take a moment and think about this. Tangent of 3 pi over 4. And sketch a little picture. 3 pi over 4. 3 pi over 4 is going to be in the second quadrant, and the reference angle here will be pi over 4. And so there's our 3 pi over 4. In the second quadrant, all students take calculus. In the second quadrant, tangent is going to be negative. And so the result of this is going to be negative something, and the value of pi over 4, so sine over cosine, both sine and cosine of pi over 4 is root 2 over 2. So this will be inverse tangent of negative 1. And now what we need to do is we need to find the inverse tangent of negative 1. And here's where paying attention to the domain and the range matters. Because when we think about the tangent function, for the inverse tangent, we're going to result in an angle, or we're going to get a result whose angle is between negative pi over 2 and pi over 2. In other words, it's going to be on this part of the circle. And so the question is, for this part of the circle, we're going to get that negative 1 value? Well, it turns out it's going to be over here, like that. And so the value is going to be negative pi over 4. Again, the reference angle is still the same, pi over 4. It's going to be negative because we're in the fourth quadrant, and that's because tangent is negative. And so this shows you that you have to do a little bit of work and just have to be careful and pay attention to what you're calculating. And specifically, when you're doing these inverse functions, pay attention to the range. What quadrants are these angles going to be in based on the definitions of the functions? So what happens if the composition goes the other way around? What happens if we want to take a trig function and evaluate that on an inverse trig function? What does that look like? Well, here's an example. Sine of the inverse cosine of 4/7. What can we do with this? Well, it turns out that these calculations are actually more readily computed than the other way around. And that's because we don't ever need to actually figure out this angle. We will never actually know what this angle is in this entire process. It's just some angle that does the thing that we're looking for it to do. So remember that the inverse cosine is an angle, and it is the angle that satisfies the property that cosine of theta is equal to 4/7. Now, we've done work with this earlier, but just to remind you, so there were two ways we can go forward from here. We can either use a geometric approach or an algebraic approach, and whichever one you use is fine. But the big point here is that this angle theta we want to take the sine of this thing eventually. And we can't do it by directly doing this, but we do have methods to get from knowing that cosine of theta is equal to some value to getting the sine theta. Now, I typically go with the geometric method, but again, the algebraic method will also work. So what's the geometric method say? Cosine. We have the right triangle relationship, SOHCAHTOA. Cosine is adjacent over hypotenuse. And so this allows me to draw a triangle that represents the angle theta. The adjacent side is 4, and the hypotenuse is 7. From this, we can use the Pythagorean theorem to get this other side. So let's do that. So 4 squared plus b squared is equal to 7 squared. 16 plus b squared is equal to 49. Put this right here. Subtract is going to be 33, so b is equal to the square root of 33. Right? And we are interested in sine of theta. Sine, SOHCAHTOA, is opposite over hypotenuse. And so this is equal to the square root of 33 over 7. If you wanted to do the algebraic approach, what you would do is you would go back to one of the Pythagorean identities. In this case, sine squared theta plus cosine squared theta is equal to 1. We have our cosine theta. It's 4/7, so we can plug that in. Sine squared theta is equal to, plus 4/7 squared is equal to 1. Sine squared theta plus 16 over 49 is equal to 1. We subtract sine squared theta is equal to 49 over 49 minus 16 over 49 is going to be 33 over 49. Sine of theta is equal to square root of 33 over 7. We technically have to think about the plus or minus case in this situation, and by looking at the angles, we can see that since this is going to be, since this is a positive value, the cosine is positive. We are either in, all students take calculus, we are in either the first or fourth quadrant, and we'll take the inverse sine of it, since it's positive, we're in the first quadrant, and so when we take the inverse sine in the first quadrant, it'll also be positive.